Hello everyone, I am Gaopeng from Swan Company. I am very pleased to be invited to share my topic, which is about reshaping intelligent computing with the first RISC-V intelligent PC processor. Since the wave of artificial intelligence, the computing field has been undergoing a revolution, especially with the emergence of ChatGPT, which has accelerated the storm of intelligent computing due to its low cost and low latency. Privacy considerations make running large model inference locally on the terminal the next hot topic. There are several requirements for running large model inference in the terminal. First, it needs full modal interaction capability. Second, it needs strong patent support. Third, it needs to be able to store and access personal data while ensuring privacy. Finally, a low-cost personal computer can meet these requirements well. It is the ideal hardware platform for running large models in the terminal. As a loyal supporter of the RISC-V instruction set architecture, we are thinking about a question. How can RISC-V win in the market competition of AI PC? Our answer to this question is the performance and ecosystem of intelligent computing. Let's take a look at the SG2300&SG2380 terminal processor that can support running large models, which will be launched in the summer of 20 years. On this processor, we have designed a computing power of 24 TOPS INT8 and 16 T-flops FP16. It adopts 128-bit low PDDR4X, which can provide a bandwidth of 68 GB per second and a capacity of 16 GB. It integrates 8-core ARM CA53, which allows SG2300X to be used as both a co-processor and a main control processor. In order to meet the needs of video and image analysis, SG2300X supports H.264 and H.265 video encoding and decoding and JPEG image encoding and decoding hardware acceleration, provides 16-lane PCIe Gen 3 endpoint or 8-lane endpoint plus 8-lane root complex. When it is used as the main control processor, it can provide dual gigabit Ethernet interfaces for high-speed interface communication required by PCIe expansion. SG2300X supports high-speed local large model operation. Taking Llama 2 7B as an example, it can achieve high performance of 12 tokens per second. In addition to large language models like Llama, SG2300X also supports models such as Stable Diffusion for text-to-image generation, models such as Emote Voice for text-to-speech conversion, and models such as Whisper for automatic speech recognition. Various AI models running on SG2300X demonstrate high performance, such as Stable Diffusion, which can generate a 5.12 pixel image every second. SG2300X excels in AI model execution. The high performance in terms of computational acceleration comes from our self-developed software TPU. From an architectural perspective, it can be seen as an ultra-long SIMD architecture. It has a tensor instruction unit and multiple computing clusters. This greatly saves the area of control logic. Each learn contains a cube for matrix multiplication, a vector calculation unit, and a local memory and data channel calculation unit are used. One source of data used is local. This way, the memory of EARN meets the principle of layer-by-layer calculation. Another source of data comes from the broadcast data of TIO, which allows us to fully utilize the reusability of data when performing convolution and matrix multiplication. The entire TPU has a unique data interface. The structure of this TPU can be accessed by external processors or DMA engine. We have been designing and iterating since 2016 to achieve top-notch efficiency in the utilization of various AI models. The accompanying compiler is also extremely comprehensive. Despite the high performance of SG2300 in running diverse AI models, we have encountered several drawbacks during the product promotion process. The initial drawback is there are many difficulties in expanding the ecosystem of self-developed field accelerator software. Secondly, the performance of the CPU as the main control processor is not powerful enough. Thirdly, the lack of GPU limits the application of this processor in scenes with display requirements. Fourthly, The interface is not rich enough in the application scenarios as the main control processor. These shortcomings also prompt us to think about how to design the next generation of products, especially the AI accelerator part first of all. To provide cost-effective and energy-efficient AI computing power, we believe that the direction of domain accelerators is correct. To make the programming model more user-friendly, we think that combining domain accelerators with RISC-V is a great idea. RISC-V has the characteristics of being free and open, and it supports users to do customized designs, making it an ideal platform for architectural innovation. On the other hand, RISC-V's ecosystem is relatively mature and has broad consensus. By combining domain accelerators with RISC-V, a more robust ecosystem can be achieved. We have witnessed a multitude of products in the industry that have embraced this technology route, including Tesla and TensorTorrent's AI accelerators. In terms of software, NVIDIA has initiated the prohibition of reverse engineering of CUDA, which renders the technology pathway that focuses on GPGPU and is completely compatible with CUDA potentially hazardous. And using the method of independently developing various TPUs and NPUs will encounter the ecological bottleneck mentioned earlier. We believe that based on the RISC file instruction combined with storage and calculation fusion and other technologies, designing a completely open source graph compiler programming language and compiler will be the trend and a path to success in the future. Based on this thinking, we start designing the next generation AI accelerator with the RISC-File plus SolventPU solution. In the RISC-File section of the AI accelerator, we opted for SiFile's X280, which provides a continuous, simple, high-bandwidth V6 interface. Through this interface, we can connect the CPU and software TPU. We designed the IFE unit to manage the instruction queue through the V6 interface, ensuring efficient processing and seamless communication between components. The MU module implements access to internal data of TPU in X280 through one code and dependency check. The DMA module is responsible for data transfer between TPU and DRAM. In this way, we tightly integrate SOPHON TPU and X280 into a dedicated accelerator based on the RISC-V architecture for the AI field, providing efficient processing capabilities for artificial intelligence applications. With this hardware, our software station has also undergone major renovations. At the upper level, we support different mainstream AI frameworks. The TPUMLA in the toolchain is a graph compiler for self-developed AI models. It is developed based on MLIR. At the same time, we will provide a high-performance operator library that supports more than 20 commonly used AI operators. The parallel programming language here will mainly be based on C+ syntax, supporting X280's vector instructions and TPU's tensor instructions. All of these software will be unified offline to the LLVM layer. We will open source the stack to achieve better AI performance. The next generation of processor products will provide a large computing power of 32T OPS INT8 and 16T flops FP16, a large bandwidth of 20 GB per second, a large memory capacity of 128 GB, and wide support for various languages and visual AI algorithms. It can achieve super performance in running various AI models on terminals. Our goal performance is to achieve more than 16 tokens per second running the Llama 213B large model locally on the processor, and achieve twice the performance of SG2300X on large language models. The next generation of products in terms of the main control processor will adopt the high-performance RISC-V processor SiFive P670. Its single-core performance reaches more than 12 points per GHz, which is about 20% higher than ARMA76. It supports hypervisor extension. Vector extension and MSI support up to 16 processor cores, supporting secure functions and encryption extension instructions similar to ARM TrustZone. Based on our research results, this is currently the highest performance single-core RISC-V processor available, making it possible for RISC-V to enter the high-performance terminal scene. Our target market for the next generation of products is AI PC, the Advanced Intelligent Personal Computer market. So we not only need to supplement the GPU, but also require a high-performance GPU that can achieve desktop level. We opt for Imagination's PowerVR, which has a 30-year history and a product line that supports various application scenarios like mobile, consumer, automotive, and data centers. PowerVR GPU utilizes a mature TBDR architecture based on Tail's efficient rendering, supporting standard APIs for graphics processing and rendering tasks. CPU and operating system are fully compatible and support hardware virtualization. The GPU itself also includes a small firmware processor for self-diagnosis and debugging. These advantages make us choose PowerVR after investigation and comparison. PowerVR GPU is also the best choice for RISC-V instruction architecture chips. Our forthcoming product will utilize Imagination's AXT1652 as the integrated GPU. This GPU core is capable of achieving desktop-level application performance, rendering 16 pixels per cycle and providing support for the Vulkan Graphics API. Users of these mainstream graphics frameworks can also utilize OpenCL to invoke the computational power of this GPU. The computational power can reach 512 FP32 operations per cycle. This GPU also supports pure hardware virtualization. Up to a maximum of 8 different guest operating system tasks can be directly issued to the hardware without requiring host driver forwarding. So we developed the Oasis Generation 1 SG, which is a RISC-V processor for personal computers, specifically designed for terminal applications on a large scale. 2380 SG2380 is the initial processor founded on the high-performance General RISC file CPUP 670 and the RISC file CPX 280 for artificial intelligence applications. SG2380 is the initial product in the terminal processor domain to closely connect RISC file and artificial intelligence. We anticipate SG2380 will emerge as the favored development platform for RISC file and artificial intelligence in the terminal domain. Here are the full specifications of SG2380 with a large computing power of 32T OPS NT8 and 16T flops FP16, a large memory bandwidth of 20 GB per second, and a large memory capacity of 128 GB. This allows SG2380 to provide super performance for terminal large model inference. The 16-core 3-file P670 makes SG2380 a high-performance RISC file terminal platform. Imagination's desktop-class GPU provides support for various application scenarios, hardware encoding and decoding support for multiple video formats, and a selection of multiple video output interfaces to ensure high-quality multimedia effects and excellent user experience. It has rich expansion and peripheral interfaces. The Oasis Generation 1 SG2380 will be launched in Q4 this year. Stay tuned. That's all I want to share. Thank you all for watching.